So hello everyone, my name is Sarthak and in today's video I would be covering binary search. And if you find value in this video, then please do subscribe because I'm trying to reach about 100 subscribers on my YouTube channel. So without further ado, let's get started. So what are we studying today? We are studying binary search, right? I'm new to this pentap thing, so it would take me a while to get used to it, right? So what is binary search? See, we all have studied arrays. What are arrays? Arrays are basically continuous blocks of memory where some data is stored in a linear fashion, right? Now, for example, we have 1, 2, 3, 4, 5, 6, 7, and 8 in this array, right? And the index is 0, 1, 2, 3, 4, 5, 6, and 7, right? So what we have is an array, and here I have shown their indexes, right? Indexes. Now let's go back to linear search. What is linear search? Linear search says that I am given an array and I am given a target. Let's suppose that this is my array and the target is 5 and I have to return index of the target, right? So for that, what I would do is in linear search I would go to firstly 1, this element, and say is 1 equal to target, which is 5? The answer is obviously no. So what we would do is that we would say, okay, this 1 is not the right answer, right? But okay, leave it. This 1 is not the right answer. So let's move the pointer over here, right? So now my pointer is over here. Is 2 equal to target? The answer is no. So we'll again move the pointer and we'll go till the end of the array till we find the answer, right? So 2 is not there, so we've moved to 3. Is 3 equal to 5? No. Is 4 equal to 5? No. Is 5 equal to 5? Yes. So we would return 4 as answer. Now let's go to time complexity. What would be the time complexity of this? Just a second. Yeah. So we have 1, 2, 3, 4, 5, 6, 7, and 8. Target is 5, right? Now, for example, I increase the size of the array. Let's suppose 9, 10, and we go till some value n. This is index n minus 1, right? So we are going to n, and let's suppose that uh, my I want to search n plus 2 in this. My target is n plus 2. So obviously n plus 2 is not in this array, because n plus 2 should have been on the right of this array, but the array is ending over here. So array is ending over here, so we don't have n plus 2 in this array, right? Now if we see, as n increases, the time for us to say that, oh, n plus 2 does not exist, also increases, because we have to do more searches in this, right? Now this is what we call time complexity, that as input increases, our time or comparison increases, and these are directly proportional, meaning that they increase in a linear fashion. So they increase in a line where x is input and y is output, right? Now what we can do is that, and to display this we use the big O notation. So this is linear time complexity. Now you might ask, okay Sarthak, we get your point that n plus 2 is out of the array. So as we increase the size of the array, the number of comparisons are increasing, and because the number of comparisons are increasing, we are getting O of n time complexity, right? Can we do something better? Can we do something better? Let's see. This is what we'll solve with binary search. I'm new to this, so I'll improve this erasing part. You can just skip the video if you want, right? So let's go to binary search. Binary search, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Now notice one thing in this array. This is sorted. And this is a very important point. Note, this is very important, right? That binary search, whenever you see a sorted array or a nearly sorted array, you use binary search. Always think of binary search when you see something is sorted or nearly sorted, right? Now, what is the concept? The concept is that linear search was happening in O of n time. We want to make it O of log n time. O of log n basically means that as the input increases, the time increases with O of with the factor of log n. Okay, so that is what this means. Let's remove this. Now let's go to start. This is my first index start, and this is my last index end. Now what I am going to do is, okay, start is equal to array of 0 and end is equal to array of let's say we have array dot length -1, right? So this is my start and end. Array of 0 because this is on the 0 index, and end is basically the length is 9, as you can see. Length is 9, but if you see this indexing is starting from 0, that's why I did -1, and then I simply indexed it and got the value 9. And another thing, sorry, this we won't be indexing over here. We are just taking the indexes as start and end, right? Now after that, what I say is that Sarthak, okay, you are at 0, starter is at 0, end is at 8. What is in the middle? 4. How do we find the middle? Start plus end divided by 2. Or a better way is start plus end minus start divided by 2. This is a better way while writing the program. Now, why are we using this way? Because your doubt may be that this might take more computation. Let's say your values are integer dot max and start is integer dot min. Basically what it means is that we are trying to avoid out of bound error, that okay, end and start should basically be in the numeric range, and they should not exceed, like a data type int, if it has a particular particular size of memory, right? If it exceeds, then we get some overflow error, and that returns a very ambiguous answer. To avoid that, we use this, right? Basically not to go out of the range of the data type which it is specified, right? After that, this is start, this is end, this is my this is my mid. Now I am finding 7, for example, t equal to 7. So I see is array the element at middle, is it equal to 7? The answer is no. Right. Now is it less than 7? I'll tell you why we are doing this. Is this less than 7? Yes, this is less than 7. Now as this is a sorted array, this part would always be less than 5 and this part would always be greater than 5. Now as we can see that 7 is greater than 5, meaning that we would find our answer in this array. So the basic motto of binary search is to reduce search space. So we are trying to reduce search space. Now to reduce our search space, what we'll do in code, we'll just write start, we'll change the position of start. Start and end are giving our search space. Now I want my search space to be this. So I'll just move my start here. So for that I'll tell the code that okay, make start equal to mid plus 1. Right. So start comes over here. Now I'm searching in 6 to 9 and the index is going to be 5. Right. 5, this is 8. Now let's calculate the middle again. The middle is 5 plus 8 by 2. And we always take the floor value of this. So we would take floor value of this. Okay, it's not represented like this. Floor is represented like this, if I'm not mistaken. Right. So 8 plus 5, 13. 13 divided by 2 is 6.5 and 6.5 floor is 6. So our mid is over here. Is array of mid equal to 7? Yes. Index mid is our answer. And that is how we do binary search. And as we are finding the mid, so with every step our search space gets halved. That's why we have O of log 2n complexity. Because what is log basically? Log is, for example, if you have 2 raised to the power of x equal to n, then x is basically log of n base 2, right? And as we can see that our search space is always getting divided by a factor of 2. That's why our complexity is being O of log n base to the power of 2, where n is basically number of input elements, right? So this was binary search, and now I think it's time to code it. So I'll keep my pen tab on this side and let's start with binary search. So I'm going to have my bash over here. So I want to go to home. Where is home? So I'm going to make a directory learning binary search. CD learning binary search. Then I'll say I want to write a code touch main.java, and in this code I am going to basically open my VS Code in this. So I'm waiting for my VS Code right now. So this is my main.java file. I'll be coding this in Java. Yes, it was the authors. So let's start. So first I'll define my class main, because the name of the file is main. Public static void main. Basically I'm defining the main method of my Java file. After that I'm going to define an array. So let's say it's an integer array, and I say the values are 1 2 3 4 5 6 7 8 9, right? And the target is 7, and the answer expected should be what was there in our whiteboard. The whiteboard is saying our mid was here at 6. So the answer for this should be 6, right? 6. Let's check this also. 0 1. So it's following the pattern. Value is equal to index plus 1. So basically index is equal to 6, so the value we should expect is 6. Now I'm just going to print out the value. Binary search, and in this I'm going to take my array and my target, and we don't have our method right now, so I'll just make the method as well. Private static, and I would return an int. Okay, and we can do linear search as well. I'll show you linear search as well. So let's first code linear search. Int array, int target, for int value in array. No, this won't work because I want to return the index. For int index equal to 0. Index is less than array dot length index plus plus if our array of index is double equal to target, then just return index. else if we are not able to find our target in the array, then what would happen is that so for example, if we have to find 10, it would go to 1, no, 2, no, 3, no, 4, no, 5, 6, 7, 8, 9. We have reached the end of the array. The loop is basically to traverse the array. Okay, that first go to 1, then go to 2, then go to 3, and we are going to till 9. After that, it would say, okay, the loop is empty, I did not find my target value 10, so I'll just return -1. So that's what I'm. So let's go back over here, and I'll just say if you don't find, return -1. Okay. Similarly, what's the error over here? Insert fire. Okay, I'll look into it. It isn't a big deal. Okay, after that I go to private static int binary search, and in this I have my array int target. What is this? Method header name. Pretty buggy. I don't see any issues in this. This should be public class main. Public class main. Public static void main. String args. Int array equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Sometimes this happens while coding. You get stuck somewhere and you have to resolve the issue, right? So I'll say private static int linear search int array int target. If my for int index equal to 0, index is less than target. What is this issue? Index plus plus. If my, I think I didn't put a semicolon there, but okay, no worries. If my array of index is equal to target, then return index and return -1 if I don't find anything, right? And index plus plus. Now what's the issue? If I run this, what's the issue? Nothing's the issue. The I think VS Code is unnecessarily giving me issues, which I wasn't expecting. Yeah, it's running. And if I, for example, say 11, 12, index out of bounds, okay. If array of index, okay, this is pretty wrong. Array of length, -1. Now it should be working, but I am going to test this. I wasn't expecting this. So let's have a value which is less than the current values. So let's say -45. A value which is in the array, so let's say 5, and a value which is out of the array, so let's say 11, right? Then let's see the output. So -45 is obviously not in the array, so it gave -1. 5 is in the array and at the index 4, so it returned 4. And 11 is not in the array, so it returned -1. Okay, our linear search is working. So sometimes what happens is that we encounter such issues. The key to solving such bugs and encountering such issues is to thoroughly, firstly, whenever you code something, test it. Test what is happening. The second thing to keep in mind is always try to use linters and try to use strongly typed languages, right? So for example, where we can define types of our variables, so we know that okay, correct inputs and outputs are happening, right? So always test your code, always make sure that you have like considered all the edge cases, and before you push anything to production, always try to see that okay, this is my code, is this code thoroughly tested? Okay, this is thoroughly tested, good. Have I covered all the edge cases? Is there any edge case which I might have missed? Okay, that is also done. Then think, is there a better way to optimize this? Is there a way to make this more efficient in terms of time or memory? Or the fourth part is that okay, I am developing this feature, but does this feature actually lead to growth of the business? And if I have to make this feature, am I making it for the short term or the long term? So in initial stages of programming, this would seem like a very minor issue, that okay, there was some bug, we fixed it. But in the overall perspective of things, you have to look at the whole picture, and you have to thoroughly test your code and look at the edge cases, right? So now let's move to binary search. Private static int binary search, and we have our arguments int array and int target. And for int index, okay, so what I'll do is that I'll say my int start, which is an index, is equal to array of 0. Sorry, it is 0. Why do I keep writing array of 0? and this is int end is array of length minus 1. Now I always prefer to calculate the length separately and then use it in programs, because I find it to be more of a good practice and more efficient in some ways, right? So now I have my start and then I have my end. So while start is less than end, I want that if, okay, first I'll calculate my mid. So int mid equal to start plus end minus start divided by 2. If my array of mid is double equal to target, if I am able to find my target, then return mid, which is the index. If not, then I am going to use else if here, and array of mid is greater than target. And note, this is an ascending order array, this is increasing. If this was decreasing, then we would reverse the signs, right? But as this is increasing, then we can use this. Okay, so if my array of mid is greater than target, so what this is basically means is, for example, if my target is 3 and array of mid is 4, then I want my end to come over here. So my end would be equal to mid minus 1, else my start would be mid plus 1, right? And if I don't find this, I'll return minus 1. So this is my code. Now what is this issue? Binary search int is undefined. Int type main. Okay, let's see. Now I'm going to do binary search. Binary search, binary search, right? So I have my binary search over here, and let's run this, because yeah, so this VS code is giving me, for some reason, I don't know what's with VS code today, but it is running. If I also write system.out.print ln binary search and I go to the terminal, I write java c main.java. So basically I am compiling my Java code into a bytecode. Okay, we missed a semicolon over here, that's no big issue. And okay, we have our main.java file, and we also made our main.class file. If you see the contents of the main.class file, then you would find something like this. This is basically our bytecode, right? So now let's run our Java code. So Java main, so binary search -1, 4 and -1, right? So we are getting our correct outputs over here. So this was binary search. I hope you got to learn something new from this. And if you liked the video and found value in this video, then please do consider subscribing, as my target is to reach 100 subscribers on YouTube. And thank you very much for staying till the end. And I hope you the best in all your future endeavors. So thank you very much.